In the exercise today, we're going to talk about relationship of chord lengths and arcs. Copy into your notebook the 3 theorems from Daily Test 39. These were posted on Google Classroom on March the 1st, and they were due March the 4th. You might want to pause the video while you do this. In order to explain these, I'm going to move down to the bottom of the page. We'll start with Theorem 9.4. I have chord AB and chord CD. Chord AB is the chord of arc AB, and likewise, chord CD is the chord of arc AB. In the same circle or congruent circles, Theorem 9.4 states that congruent arcs have congruent chords and congruent chords have congruent arcs. So, if chord AB is congruent to chord CD, then, if arc AB was congruent to arc CD, then chord AB will be congruent to chord CD, and vice versa. If the chords are congruent, then the arcs will be congruent as well. To the right of that, since we have diameter BD, which also contains radius BO, and part of that radius is segment XO, each of those is perpendicular to chord AC. According to Theorem 9.5, a diameter that's perpendicular to the chord bisects the chord and its arc. All right? So, segment BO and diameter BD are both perpendicular to AC, so it bisects chord AC and it bisects arc AC. Not only is that true, at the bottom in the yellow, major arc AC would be bisected into the 2 minor arcs, arc AD and arc CD. Now let's look at Theorem 9.6. Here we have chords AB and CD. The distance that chord AB is from center O is marked in green, OE. And I'll put a little mark on that. We've learned previously that the distance from a point to the line is the perpendicular distance from the point to the line. Likewise, the distance from O to P is the distance that chord CD is from the center O. According to Theorem 9.6, in the same circle or congruent circles, chords equally distant from the centers are congruent, and congruent chords are equally distant from the center. So, if segment OE is the same distance as segment OP, then chord AB will be congruent to chord CD, and likewise, if chord AB is congruent to chord CD, then their distances OE and OP will be equal as well. Now let's look at some problems up here. And we're going to scratch this right here to say at the side. First we'll look at 4 and 5. What do we have in 4? We have chord AB, and OM is perpendicular to it. Therefore, what does OM do to AB? It bisects it. I won't write AB is 16. I will write that AM is 8 and MB is 8. We're told that OM is 6. Look what we have. 6, 8, what? That comes from the 3, 4, 5 family. And by doubling 3, 4, and 5, what do we know goes in that blank? Sure, 10. What if we didn't recognize it was a family? As usual, we could use the Pythagorean theorem. Hypotenuse squared, and we'll put an X on the hypotenuse of, let's use this right hand triangle. We'll put an X there. Hypotenuse squared equals leg squared plus leg squared. And when we solve for X, we will get 10. On the other picture, PQ is 10. We're not going to write 10. Since OM is perpendicular to PQ, it bisects it. What are we going to write then? 5 and 5. It tells us that the distance of the radius is 13. That means from O to P, from the center to a point on the circle, is 13, as well as from O to Q is 13. Let's look at one of these two right triangles. What am I missing? I'm missing one of the legs. 5 is a leg, I'm missing a leg, and 13 is the hypotenuse. 5, what? 13. We all know that it is 12. Again, a family. What if you don't recognize the family? Use your Pythagorean theorem. Hypotenuse squared equals leg squared, that's the one we know, plus the other leg squared, that's the one that we do not know. You would still get 12 when you solve for X. Now, back to 3. Study the diagram at the side and tell which theorem justifies each statement. How do we know that LK is 8? Well, since OE is perpendicular to LK, it bisects LK. If LE is 4, then at the bottom of that chord, EK will also be 4. What does that make the entire length of chord LK? 4 plus 4, or LK is 8. That's using Theorem 9.5, which says a diameter that's perpendicular to the chord bisects the chord and its arc. Now let's go another step. How can we figure out that OE is 3? We know that chord GH is 8, and we just figured out that chord LK is 8. They are congruent chords. According to Theorem 9.6, in the same circle or congruent circles, chords equally distant from the center are congruent, and congruent chords are equally distant from the center. So since those blue chords are equal, their distances to the center must also be equal. They must both be 3. That's using Theorem 9.6. Now let's go to part C. How do we know that arc LK is congruent to arc GH? Well, back in part A, we determined that the two blue chords, segment GH and segment LK, were congruent. According to Theorem 9.4, in the same circle or congruent circles, congruent arcs have congruent chords, and congruent chords have congruent arcs. So, since chord GH and chord LK are both 8, then their arcs, arc GH and arc LK, will be congruent. That comes from Theorem 9.4. Now you have a few exercises to work on this section.